This video shows you how to do calculations involving titrations. Now, titration is a very useful method which can be used to find the concentration of an unknown substance. So just to give you an example, one of the applications is in finding out what the concentration of sodium hydroxide you require to neutralize a known concentration of an acid such as hydrochloric acid. Now, titration is a required practical, so you need to know how the method is done, but the main purpose of this video is to show you how to do the calculations. So the first thing we need to know is the balanced symbol equation for this reaction. So let's start with hydrochloric acid. We react that with sodium hydroxide, and that produces sodium chloride plus water. Okay, so this equation is already balanced because we can see that there's two hydrogens on the left hand side and two hydrogens on the right hand side. One Cl on the left and one Cl on the right. One Na on the left, one Na on the right, and one oxygen on the left and one oxygen on the right. So this is already balanced. Okay, so if we were to describe this reaction, we can say that 1 mole of HCl reacts with 1 mole of sodium hydroxide to give you 1 mole of sodium chloride and 1 mole of water. Okay, and so a word that you need to use, that you need to know, is stoichiometry. And stoichiometry basically means the ratio. Okay, the ratio of the substances. So here we have a 1-to-1 ratio, okay, between the acid and the alkali. So 1 mole of hydrochloric acid will react with 1 mole of sodium hydroxide to give you 1 mole of sodium chloride and 1 mole of water. Okay. Now, if we had 0.5 moles of hydrochloric acid, because of the stoichiometry, we need 0.5 mole of sodium hydroxide for this reaction to proceed, which will give us 0.5 mole of sodium chloride and 0.5 mole of water. Okay. Now, if we knew the concentration of our acid and our alkali, then we can work out how much volume we would need of the alkali to neutralize a known volume of the acid. Okay, so let's start off with a really easy one. So imagine that we had a 0.5 molar concentration of HCl. Okay, and we also had a 0.5 molar concentration of sodium hydroxide. Okay, if they were the same concentration, then we would need the same volume of sodium hydroxide to neutralize the same volume of hydrochloric acid, okay, because they have the same concentration. Okay, so just to give you an example, if we had 10 centimeters cubed of hydrochloric acid, we would therefore need 10 centimeters cubed of sodium hydroxide to completely neutralize the acid, because they have the same concentration. Okay, does that make sense? Okay, now, if for example, if we had 0.5 molar concentration of HCl, but then we had a 0.25 molar concentration of sodium hydroxide, because the concentration of the alkali is half that of the acid, we would now need double the volume of sodium hydroxide to neutralize a known volume of hydrochloric acid, because this has double the concentration. Okay, just to give you an example, if we had 10 centimeters cubed of hydrochloric acid, we would now need 20 centimeters cubed of sodium hydroxide to completely neutralize our acid. Okay, because the concentration is half, so we need to have double the volume, okay, in order to neutralize that. I hope that makes sense. Okay, and just to remind you that our formula, which is concentration of a solution equals the number of moles over decimeter cubed. Okay, so 1 decimeter cubed. 1 decimeter cubed is the same as 1 liter, which is also the same as the number of moles in 1,000 centimeters cubed. Okay, because 1 liter or 1 decimeter cubed is equal to 1,000 centimeters cubed. Okay. Okay. Now, in the required practical for the titration, you are given a burette, which you fill with acid, and you have a conical flask with a known volume of sodium hydroxide. Okay, so in here, in the burette, you have, let's say for example, 0.4 molar concentration of HCl. Okay, and in here, in the conical flask, you have 25 centimeters cubed of sodium hydroxide, okay, with an unknown concentration X. And in the required practical, you have to try and calculate what the concentration of the sodium hydroxide is. Okay, and in order to do that, you first have to obtain some data to find out the volume of 0.4 molar hydrochloric acid that you require to neutralize sodium hydroxide. Okay, and you know it's neutralized when your indicator changes color. So let's say for example phenolphthalein. Phenolphthalein is pink initially in an alkali, but when it's neutralized, it becomes colorless. So when it becomes colorless, then you note down how much volume of 0.4 molar hydrochloric acid you have used. So you normally have to take 3 sets of readings and then take an average. Okay, and let's say for simplicity's sake that the average was 12.5 centimeters cubed. Okay, so this is the average of 3 sets of results, 12.5 centimeters cubed. Okay, now with this data, you're expected to calculate and work out the concentration of the sodium hydroxide. Okay, and some people do find that tricky. Okay, but we're going to go through it step by step. Now, one of the ways in doing calculations is think about what information do you have at the beginning and what information do I need to answer the question. Okay, so what information do I have at the beginning? Well, I know that my hydrochloric acid is 0.4 molar. Okay, and I used 12 0.5 centimeters cubed. Okay. And what I want to find out is the concentration of NaOH. Okay. And if you remember earlier, that concentration is equal to the number of moles over volume, okay, which is in decimeter cubed. Yeah. Now I don't know what the concentration is, and I don't know the number of moles, but I do know what volume of sodium hydroxide I used at the beginning. Okay, so let's write this out on a separate line. So I do know that I started with 25 centimeters cubed of sodium hydroxide. So what I need to do is, in order to find out the concentration of sodium hydroxide, I need to also find out the number of moles. Okay, and how do I do that? Well, if we look back at our equation, we know the stoichiometry is 1 mole of hydrochloric acid can be neutralized by 1 mole of sodium hydroxide. So it's a 1-to-1 ratio. Okay. So if we have a look, 0.4 molar, we can rewrite that as 0.4 moles per decimeter cubed, right? Or we can write that as 0.4 moles in 1,000 centimeters cubed. Okay, because that is the formula for concentration, moles over volume. Okay, now what other information do we know? We know that we needed 12.5 centimeters cubed of the acid in order to neutralize the sodium hydroxide. So all we need to do is work out the factor that we have to adjust by. So to get from 1,000 to 12.5, we can work out that factor. So the factor is 1,000 over 12.5. So 1,000 divided by 12.5 is 80. Okay. So always good to put the units down so it's clear what the numbers are showing you. So to get from 1,000 to 12.5, we divided by 80. Okay, so we need to do the same for the number of moles. So if we divide by 80, okay, divide by 80, that gives us 0.005 moles. Okay, which makes sense. If we have a lesser volume, we have a lesser number of moles. Okay, and it has to be by the same factor. Right? Now, because we know that we have in 0.005 moles in 12.5 centimeters cubed of the acid, okay, and because we know that we don't have 1 mole at the moment, we have 0.005 moles of HCl. We also have 0.005 moles of sodium hydroxide, okay, because that's how much they need to neutralize each other, 1 mole of each here, or the ratio. So if we had 0.005 moles of hydrochloric acid, we also have 0.5 moles of sodium hydroxide. And now that we know the number of moles of sodium hydroxide, we can work out the concentration of the sodium hydroxide. So let's use our equation. So now we have 0.005 moles in 25 centimeters cubed. Okay. Now, concentration is given in decimeters cubed or in 1000 centimeters cubed, right? So we have to adjust for that. So the concentration of sodium hydroxide, okay, is equal to, so if we adjust that, so if we get our 25 centimeters cubed and we multiply that by 40 to get 1000 centimeters cubed, we also do the same to the number of moles. So 0.005 times by 40 gives you 0.2 moles. Okay, now this is the same as 0.2 moles over 1 decimeter cubed. So now we know that X, which is the concentration of sodium hydroxide, is equal to 0.2 molar. Okay. So hopefully that makes sense. It's always good to show all your workings out, always include the units, and be very clear when you are writing it step by step. Write them on a new line every single time. If you didn't get this entirely, then I suggest you go back over the video and just pause at certain points to make sure that you understand every step of the way of the calculation.